Well, hi everybody. Today is day 2 of chapter 10, and we are working on arcs and chords, measuring them and figuring out lengths and so forth. So, let's take a look. This theorem says that if the arc, if these two arcs are congruent, then these two chords are also congruent. So that's basically one of the theorems that we have. If the arcs are congruent, then the chords are congruent. This theorem says that I have this diameter, and if it's perpendicular, if a chord is perpendicular to the diameter, then this chord is bisected, and this arc is also bisected. All right? And then, if we have these two chords here, they are congruent only if they are the same distance away from the center. So if this is congruent to this, then the two chords are congruent. So when we're doing stuff like this, we're going to be setting a lot of things equal because we're talking about congruent stuff. So in this figure, it says that circle A is congruent to circle B, and WX is congruent to YZ. So WX is congruent to YZ. So when we have those two measurements, we're going to set those equal. So it's going to be 7x minus 2 equals 5x plus 6. So when we do the math, we end up with 2x equals 4, so x equals 2. All right, so now we're asked to find the measurement of an arc. But I'm noticing that this is perpendicular here. So that means that this is bisected, so this is 5. I'm also noticing that they're asking me to find the arc DE. They told me that this whole arc is 150. So that whole thing is 150. So now I'm looking for that red arc. Well, I know that if this is a perpendicular bisector, that means that this measurement is the same as this. So the whole thing is 150. If I divide it by 2, I'm going to find the measurement of arc DE. So 150 divided by 2 equals 75. So the measurement of that is 75 degrees. This is a little hard to see on your note sheet. In color, it looks a little bit better. But they're asking us to find the measurement of CD, which is this piece right here. Well, that's going to be weird. Okay, what's the other information that they're giving us? Okay, the diameter of AB is 18 inches long. So this whole thing is 18. Okay. Chord EF is 8 inches long. This is 8 inches. So they want me to find the part of that chord. Well, I know that these two are the same. So if that's 8 inches, then if I pull this out, No, not yet. So I know that this is 4, and this is 4. And I know that the diameter is 18, huh? Okay. Well, I know that then a radius would be 18. I'm going to take my radius and twirl it around from CB. I'm going to twirl it around to CE. Oops. I'm going to twirl it around to CE. Oh, then that radius is 9 inches. Okay, now do you see it? I have a right triangle. And I know 2 of the sides. I know this is 4, and I know this is 9. So I can find CD right here by doing the Pythagorean theorem. See, right triangles never go away. All right, so when I do the Pythagorean theorem, I'm going to say a squared plus 4 squared equals 9 squared. So I get a squared plus 16 equals 81. And I get a squared equals 65. And then when I square root that, I end up with a equals 8.1. So that is the measurement of CD. Excuse me. In the circle, it says again that the diameter is 14 inches long and the chord RT is 10 inches long. This is the same as the last problem. So I want you to do this one on your own and figure out what VU is. I will know that you listened to the video when I see that this is done tomorrow. All right, so now we're getting a little bit, we're ramping it up a little bit. In circle P, EF equals GH. It tells us that. These two are congruent. And it also tells us that GH is 24. So if this is 24, so is this one. Now they want us to find PQ, which is this length right here. So we're going to have to do a couple of steps. We're going to first have to figure out what X is so that we can plug it in to get a measurement for PQ. So what I'm going to do is, I notice here that 4x minus 3 is on one side of this chord. I'm going to put it on the other side of the chord too. So now I know that 4x plus 3 and minus 3. Whoa. Didn't catch that. 4x minus 3. So 4x minus 3 plus 4x minus 3 is going to equal 24. Because that's what I have right here on that chord. So let's do some math. So I get 8x minus 6 equals 24. So 8x equals 30. And x equals 3.75. So now I can figure out what that PQ is by plugging in x, because this measure and this measure have to be the same, because these lines have to be equidistant to make the chords congruent. So I'm going to plug in x for this measurement right here. 2 times 3.75 plus 3, and that equals 5.5. So that's the length of PQ. All right, so watermark. I don't know if you guys have seen a watermark, but that's like, even in the money now, you hold up a dollar bill or whatever, and you can see a watermark in the middle. That's what we're talking about here. So this jewelry store has a hidden watermark on their official documents. Watermark is a cord located 0.7 centimeters from the center of a circular ring. Okay, so I'm just going to draw this because it just makes more sense. So I've got a circle. Ooh, not bad. And here's the center. And a cord located 0.7 centimeters. Okay, point from the center. And then it has a 2.5 centimeter radius. Well, I can take that radius and make it wherever I want. And I can put it right there. So I have now a right triangle. So I'm going to pull that right triangle right out of there. And I'm going to say this is 0.7, and the radius, which is this guy right here, is 2.5. And they want us to figure out what the length of the cord is. Okay, so what's the length of the cord? Well, the length of the cord is this whole thing. But if I figure out this part of it, I can double it and get the whole thing, right? So, oh, here it is, Pythagorean theorem again. So, let's see, 0.7 squared plus x squared equals 2.5 squared. All right, so I do all that math and I end up with 2.4. X equals 2.4. So if this is 2.4, this is then 2.4, and the whole thing would be 4.8. Any questions? Bring them tomorrow. I look forward to seeing you. Have a good night.